In this video, we're going to look at how to solve word problems using systems of equations. So the first problem, Mount Ridge High School is putting on a holiday chorus concert. They sold 243 tickets. If the number of adults attending is 12 less than twice the number of students, how many students and how many adults will attend the concert? So why don't you press pause so you can finish copying this down so we can get started right away. Okay, so whenever we have a word problem, okay, we need to think about what's really going on in this problem. Do we understand this situation? Well, we have a chorus concert, okay, and there's students attending and there's adults attending. They sold 243 tickets, so we know the total number of people is 243, and then it gives us a sentence comparing the number of adults to the number of students. Okay, so we just have adults and students attending a chorus concert, nothing more than that. So originally we would solve this problem by guessing and checking, and I know it might be tempting to do so, but we want to get good at just writing systems of equations, because once we get good at that and once we understand how to do that, it's actually the easier of the techniques. So the very first thing we always need to do when writing equations is we've got to figure out what our variables are going to be. Okay, what are the things we don't know in this problem? What are the things we're looking for? Well, the two things in this problem are just the number of students that went to the concert and the number of adults that went to this concert. That's what this whole problem's about, finding out how many students and how many adults went to the concert. So that's what our variables are going to be. So I'm going to say, let A represent the number of adults that went to the concert, and S is simply going to be the number of students at the concert. Now we could choose any variables or any letters that we want, but it always makes sense to just choose variables that work with what they represent. Okay, A is the number of adults, S is the number of students. It helps us remember what these letters or what these variables represent. Okay, now that we defined our variables, we need to look back at the problem and look for things about these variables. We look for certain totals. We look for how these two variables are related to each other, or how these two numbers are related to each other. These help us, or these tell us how to specifically write these equations. So I noticed that they sold 243 tickets. So altogether they sold 243 tickets. Well, we know the only two types of tickets they sold were adult tickets and student tickets. So the adult tickets and the student tickets combined have to give us that 243. So that equation is simply A plus S equals 243. This equation tells us that the number of adults and the number of students is 243 total people that went to the concert. Okay, so this equation is very simple and it makes perfect sense. Now the other equation, well, we have to look for another total that it gives us, or another way these two variables are related. Well, there's no other totals in this problem. This 243 is the only total, so we need to look for something else. Well, it tells us the number of adults attending is 12 less than twice the number of students. Okay, so this relates these two variables to each other. So we need to figure out, how do we turn this into an equation? So we need to think, well, the number of adults attending is 12 less than twice the number of students. So the number of adults depends on the number of students. We think, what do we got to do to the number of students, to that number, to get the number of adults? Well, it says 12 less than twice the number of students. Well, I know twice means multiply by 2, and 12 less, that means I'm going to subtract 12. So the number of adults is 12 less than twice the number of students. So that means the number of adults equals. The way I figure out my number of adults, so I have the number of adults equals, well, I'm going to take twice my number of students. Whatever number of students I have, I'm going to multiply it by 2. And then it's 12 less than this, and 12 less than something is minus 12. So this equation, even though it looks confusing, does in fact mean the number of adults is 12 less than twice the number of students. I'm going to multiply the number of students that went, subtract 12, and that tells me how many adults went to this concert. So this is my other equation. Okay, this equation relates my two variables to each other, so we have A, the number of adults, equals 2S minus 12. Okay, 12 less than twice my number of students. Okay, now that we have our system of equations, we just have to solve it. So since we practiced a lot already, we know how to solve systems of equations no matter which form they're in. The second equation tells us what A equals. A equals 2s minus 12. That means every single A in this system, in this problem, also equals 2s minus 12. So I'm going to use the substitution method to solve this system of equations. So I'm going to substitute 2s minus 12 in for the A in my first equation. So instead of doing A plus S equals 243, I know that A equals 2S minus 12, so I'm going to say 2S minus 12 plus S equals 243. I'm just substituting 2S minus 12 in for A. Now I'm just going to simplify and solve. 2S plus S is 3S, minus 12 equals 243. Add 12 to both sides, so we have 3s equals 255. So this means s equals 85. Now we can't get lost in the algebra. We just want to understand, what did we just figure out? Well, s is the number of students at the concert. So this, what we did, all this solving, all this weird algebra, told us that the number of students is 85. 85 students attended this holiday chorus concert. That's great. But now we also have to figure out how many adults attended the chorus concert. Now this part is very intuitive. Okay, we know 85 students attended the concert and 243 total people attended the concert. So when we substitute 85 back into this first equation, when we do A plus S equals 243. Okay, the total number of people at the concert is 243. So if 85 students attended the concert, we're simply going to do 243 minus 85 to get the number of adults attending, which is 158. Okay, we just subtract 85. This is very intuitive. Okay, the total number of people is 243. So if 85 students attended, well, 243 minus the 85 means 158 adults had to attend, because A plus S, the adults and the students, had to be 243. Now to make sure we did it right, we're just going to check our answer in our other equation. Well, we also know the number of adults have to be 12 less than twice the number of students. So the number of adults is 2s minus 12, so A equals 2s minus 12. So we just want to make sure 2 times 85 minus 12 also gives us 158. Well, 2 times 85 is 170. 170 minus 12 is 158. Okay, we just did this to make sure. Again, this step is very intuitive. I know we don't want to get lost in the algebra. 243 total people went. So if 85 students, well, then we just simply do 243 minus 85 and get 158 adults. Okay, the other equation tells us that 12 less than twice the number of adults than students went to the play. So to get the number of adults, we're going to double the number of students, which is 170, minus 12 is 158. So we get, in our complete sentence answer, okay, 85 students and 158 adults attended the Mount Ridge High School chorus concert. And the reason why we write complete sentence answers is to make sure to show that we understand exactly what we did, why we did it, and what our answer represents. Okay, the next example. Okay, Cool Valley High School is putting on a holiday band concert. Okay, they charge $5 for a student ticket and $8 for an adult ticket. If they sold 368 tickets and made $2,608, how many of each type of ticket did they sell? So again, press pause, take a moment to finish copying this down so you can press play and we can get started right away. Okay. So again, this problem looks very similar to the one before, but we just want to make sure we understand the specifics of this problem and how to turn it into an equation. So the very first thing we got to do is just simply understand what's going on again. Okay, we have another concert. We still have student tickets and adult tickets. So students and adults are attending a concert. So again, it's pretty much the same situation. So if it's the same situation and we want to know how many of each type of ticket did they sell, well, we have adult tickets and we have student tickets. That's what we want to figure out. So that's what our variables are going to be. The very first thing we always have to do is define our variables. So we're going to say let A equal the number of adult tickets, and S is going to equal the number of student tickets. Okay, now that we defined our variables, we have to look back in the problem and think how these two variables are related. How can we use the information in the problem and these variables to write equations? So the two things we look for, again, we look for specific totals in the problem, or we look how the two variables are related to each other. Well, I see that they sold a total 368 tickets. So since the only two types of tickets we sell are adult tickets and student tickets, that means the number of adult tickets plus the number of student tickets has to give us our total number of tickets. So just like in the first problem, our equation is A plus S, the number of adult tickets and the number of student tickets, has to give us 368 total tickets. Okay, it's a very simple process, it's a very simple thought, so it turns into a very simple equation. Okay, now we need to look again for some other total or some other information this problem gives us. Okay, so we also see they made a total $2,608. Okay, this is where it's different than the first problem. It gives us another total. So we know since it's another total, something has to equal 2,608. So this is $2,608. So they're going to get a certain amount of money from the adults. They're going to get a certain amount of money from the tickets or the student tickets, and together it's going to be $2,608. So let's look back for the specifics in the problem. Well, they get $5 for each student ticket and $8 for each adult ticket. Well, so it's $8 for every adult ticket. So we're going to do 8 times the number of adult tickets we sell, and it's $5 for every student ticket, so we're going to do $5 times the number of student tickets we sell, and that gives us the total $2,608. So this equation really isn't that complicated either. It's $8 per adult ticket because it's $8 times the number of adult tickets we sell. This 8A tells us how much money we get from adults. This 5S tells us how much money we get from our students, and this 2,608 is the total amount of money we get. Okay, so now we have two equations. So now we need to solve it. But since we got a lot of practice before, we know how to deal with an equation or a system of equations when they're in this form. We see we have two equations in standard form because we have both our variables equal a total in both of our equations. So we're going to use the elimination method. Okay, we realize that nothing's going to eliminate right away because none of our coefficients match up. So we need to multiply something first. So I know in order to get rid of my s's, this would have to be a 5s. I need a 5s in my first equation so I could subtract off the 5s in my second equation. So I'm going to multiply every single term in my first equation by 5. This is how we solve a system of equations like this. Okay, so 5 times a is 5a, 5 times s is 5s, and 5 times 368 is 1,840. My second equation stays the same. Okay, now my s's match up. I could eliminate my s variable by subtracting these two equations. 5a minus 8a is negative 3a. And this equals 1,840 minus 2,608. We're just careful to do the operation we said we're doing. And this is negative 768. So we have negative 3a equals negative 768. We divide by negative 3, and we get a equals 256. So again, we got to be careful not to get lost in all the algebra we did. All this work told us that they sold 256 adult tickets. So we need to go back and figure out, well, now how many student tickets did they sell? Well, again, intuitively, they sold a total 368 tickets. That's what this equation says. They sold a total 368 tickets. So if they sold 256 adult tickets, that means the rest of the tickets had to be student tickets. So we're just going to do 368 minus 256, and we get the number of student tickets they sold is 112. Okay, and we just want to double check to make sure this makes sense with our other equation. Okay, they got $2,608. So our other equation is 8a plus 5s equals 2,608. So if they sold 256 adult tickets, we're going to do 8 times 256 and get 2,048 plus 5s equals 2,608. So this means they got $2,048 from the adults. So we subtract that off of the total amount of money they got. So we have 5s equals 560. So this means they had $560 left over for the students. So we divide and we get s equals 112, exactly what we wanted to get. Again, we're not getting lost in the algebra. This first equation says, well, the total number of tickets they sold is 368. So if they sold 256 adult tickets, that means the rest of the tickets had to be student tickets. So we simply did 368 minus 256 and got 112 student tickets. And we did something very similar over here, even though it looks more complicated. Both we got 112 student tickets, which is exactly what we wanted. So our complete sense answer is Cool Valley High School sold 112 student tickets and 256 adult tickets to their holiday band concert. When you're able to write complete sentence answers, it shows you understand the work you did, what your answer means, and why we did it. Okay, so let's look at some more examples, just so we get comfortable with all types of examples that we could see. So, Silver's Gym charges an initial fee of $120 plus $25 each month for its gym membership. New York Fitness charges an initial fee of $75 plus $30 per month for its membership. For how many months must one be a member so the cost of both gyms is the same? So again, press pause, finish writing it down so we could get started right away. So, this type of problem we're actually used to. We saw problems like this starting back in chapter 4, and this was never a guess and check problem. Okay, we notice both of our equations, or both of our gyms, have an initial fee and a certain growth. Okay, they have a starting amount and a certain growth. So we're actually very used to writing equations like this. Okay, Silver's Gym has an initial fee of $120 plus $25 each month. It has a growth and a starting amount. So does New York Fitness. It has a growth $30 per month and a starting amount is $75. So we're very used to and very comfortable writing equations this way. But there's still a system of equations, so we still want to get practice doing them. So whenever we have a growth and a starting amount, we like to use our x and y variables. So let's just do it here, even though other letters might make more sense. Let's just stick with what we're used to. So we're going to say let x equal. So what does x equal? Well, we're doing $25 each month. Okay, so x is going to be the number of months. So that's what this problem is growing by. This problem is growing by months. We're counting by months, so x is going to represent the number of months. And y is going to represent, well, the total cost. Okay, that's the output, that's the outcome in this problem. Okay, that's what we're getting out of our problem. When we get a gym membership for X month, we have to figure out how much we're going to pay. So y is our total cost. So again, we already have good practice doing this. This type of equation is a little bit different than the other types of examples we're working through today, but we still want to practice writing these types of equations, to review writing these types of equations. So for Silver's Gym, we got to figure out what's its equation. Well, Silver's Gym charges an initial fee of $120 plus $25 each month. So its growth is 25, its starting amount is 120, so it's very simply y equals 25x plus 120. Okay, the growth is $25 each month. The starting amount is $120 initial fee. And this is what Silver's Gym, this is the equation that represents the cost for Silver's Gym. Okay, New York Fitness. Okay, its growth is $30 per month. Its initial fee is $75, so its equation is y equals 30x plus 75. The growth is $30 each month. The starting amount is $75 initial fee, so its equation is y equals 30x plus 75. Now again, we've been solving systems like this since chapter 4, so we can't forget how to do this. These are both y equals. We have the rule for both of these gyms. Okay, so we don't use elimination, we don't use substitution, we use what we're used to using. We know what y equals in both of these. The rule for our first equation is 25x plus 120. The rule for our second equation is 30x plus 75. We want to know when these two rules are going to be the same, so we're going to use our equal values method. Okay, we can't forget our equal values method. When we have both in our rule form, both y equals, if y equals 25x plus 120 and y equals 30x plus 75, and we want to know when these two are going to be the same, we just set them equal to each other. We want to know when these two rules or when these two gyms are going to be the same, so we set each gym's equation equal to each other. So we have 25x plus 120 equals 30x plus 75. I'm going to subtract 25x from both sides and get 120 equals 5x plus 75. I'm going to subtract 75 from both sides and get 45 equals 5x. And we divide both sides by 5, get x equals 9. Again, not to get lost in the algebra, what does this 9 represent? Well, this is after 9 months, both gyms are going to cost the same. Now we just need to figure out how much will these gyms cost. Well, Silver's Gym is our y equals 25x plus 120. So it's $25 per month for 9 months. We're going to do 25 times 9 plus 120. 25 times 9 is 225 plus 120 is 345. For New York Fitness, its rule is y equals 30x plus 75. Okay, again, we have it for 9 months. We're doing 30 times 9 plus 75. 30 times 9 is 270. 270 plus 75 is 345. Okay, we're very happy because these are the same. So this means after 9 months of membership, both Silver's Gym and New York Fitness cost $345. Okay, that's what we found. Again, this is a review problem back from chapter 4, but as we see, it's still a system of equations. We still had to define our variables. We still had to remember how we solved this system of equations. We still had to find after how many months, when will both costs be the same. Okay, in our last example, Marco is playing a game. He flips a coin. If it lands heads, he gets 2 points. Tails, he loses 3 points. If he flipped the coin 100 times and he ended up with negative 25 points, how many heads and tails did he flip? So take a moment to finish copying this down by pressing pause and press play when you're ready. Okay, so again, we see we have a system of equations. We see we have a lot of information going on in this problem. Okay, so the very first thing we need to do is figure out what are our variables going to represent. Do we understand what's going on in this problem? Well, he's flipping a coin, okay, and you either get heads or you get tails. And the question's asking for how many heads and how many tails did he flip. So that's what our variables are going to represent. So we're going to say let h equal the number of heads and t equals the number of tails. Okay, those are the two parts in this problem. Those are the two things we don't know in this problem. So let's look back in the problem for any information that we get. What does it tell us about the number of heads and the number of tails? Does it give us any totals? Does it compare these two to each other? Well, the first thing I notice, it says he flipped the coin 100 times. Well, obviously, when you flip a coin, it's either going to land heads or it's going to land tails. So if you flip a coin 100 times, that means the number of heads and the number of tails gives us that total 100 flips. So we just have heads plus tails. The number of heads plus the number of tails equals our 100 total flips. Okay, again, it's a very simple idea, so that's why it turns into a very simple equation. Okay, so let's look at what else this problem gives us. Well, it says he ended up with negative 25 points. So that's another total. So something has to equal this negative 25 points. So let's look for information about the points in the problem. So it says if it lands heads, he gets 2 points, and tails, he loses 3 points. So heads is 2 points. We get 2 points for every head. So we're going to do 2 points times the number of heads we get. Now we have to be a little bit careful, but we're all smart and we all could realize how to deal with this. He loses 3 points for every tails, so we're going to subtract off 3 points for every tails that we get. So it's 2 points per heads minus 3 points per tails gives us our total negative 25 points. We have our system of equations. We realize, hey, these are both in standard form because we have our equations that equal a total. Both our variables equal a total in both of our equations, so they're in standard form. We're going to use elimination. Okay, I think, do my variables eliminate as is? Well, no, but that's not a big deal at this point because we're comfortable solving these. Okay, I think, what can I multiply by to get rid of one of my variables? Well, I notice if I multiply my first equation by 3, I'm going to get a positive 3t in my first equation. I have a negative 3t in my second equation, so those will cancel out by simply adding these two equations together. So that's what I'm going to do. I'm going to multiply my first equation by 3 so I can cancel out my t's. 3 times h is 3h, 3 times t is 3t, 3 times 100 is 300. My second equation stays the same. I didn't have to do anything to that one. So I have 2h minus 3t equals negative 25. Okay, I know my 3t and my negative 3t will cancel out when I add my two equations together because 3t plus negative 3t is 0. That's what we want. We want to eliminate one of our variables. 3h plus 2h is 5h. 300 plus negative 25 is 275. So 5h equals 275 means h equals 55. Again, we want to make sure we remember what we just did. Well, we found that the number of heads he flipped is 55. Okay, so now we just need to go back and figure out, well, if he flipped 55 heads, how many tails did he flip? So we're going to start with our easy equation. Well, if he flipped a total 100 times and he flipped 55 heads, that just means the rest of the flips have to be tails. If you flip 55 heads, that means every other flip had to be tails. So we're going to do 100 minus 55 and get 45. If you flip 55 heads, he had to flip 45 tails because altogether he flipped 100. Now to check to make sure we did the right work, we're going to look back in our other equation. Well, if he got 2 points per head, and he lost 3 points per tail and got negative 25 points. If you flip 55 heads, we're going to do 2 times 55, we get 110. So we got 110 points from the heads. Okay, and he loses 3 points per tail still, and he got negative 25 points. So we need to take away this 110 to figure out how many points he lost from the tails. So we subtract 110 from both sides, get negative 3t equals negative 135. We get t equals 45 this way. Again, this one's a little bit more intuitive. We usually use the other equation just to check our work. Again, this one was easy. He flipped a total 100 flips. So if you flip 55 heads, that means the rest of the flips had to be tails. So we simply subtract 100 minus 55 equals 45 tails. We check our work with the other equation to make sure we did it right. So we know that Marco flipped 55 heads and 45 tails, so you get negative 25 points. Okay, so if you need more examples still, refer to the textbook or some of the online resources.